In the last video, I've talked about the problem of sending out electric power from a power station directly at a voltage which is the same as what we need in our house. So if we send out 100 volts directly through the transmission line to our house over a long distance of tens or 100 kilometers, then the amount of heat loss in the cable can actually be a lot more than all the power that the power station can generate. So in order to see what happens if we use transformers to step up the voltage, let's put in some transformer. Just before the power leaves the station, we need to put in a transformer here, and just before it, or not far from our house, we need to have another transformer to step down the voltage again. Okay, so I'm just going to represent a transformer by an iron core or ring. With wires wound around the ring, so lots and lots of turns. So lots and lots of turns of wires with the ratio of number of turns of the right values to step up and step down the voltage. Okay, so typically at the power station, the transformer will step the voltage up to, say, 100,000 volts. 100,000 volts before it sends this electricity into the power cable that's going to travel up to 100 kilometers to our house. And just before reaching our house, it needs to be stepped back down again to the 100 volts that we need. So this number, this 100,000 volt, is what we need for our calculation. It is a very rough figure, and it must be quite different from place to place. So I'm just going to take this as an example for this exercise. So suppose that the voltage that comes out from the power station is stepped up to 100,000 volts. Then the electric current has to travel through this 10 ohm resistance over the 100 kilometer transmission line, power line. So let's try and calculate the power loss in this resistance. First, we must find the current, and we can do it using the same steps. Let's see what we need to change. So in this case, we want to calculate first the current. Now this time the voltage is 100,000 volts instead of the 100 volts before. If we carry through this calculation, I is equal to power over voltage. Power is still the same. We're still trying to send out this million watt power over the transmission line to our place or our neighborhood, and so that's P does not change. number for P is still 10 to the power of 6, but V has changed. Instead of 100, we now need to change it to 100,000. So I need to add some zeros there. 100 and another 3 zeros. Okay, then when I do this calculation this time, my answer is just 10, not 10 to the power of 4. So cross out the 4 there. And I'm just going to get a 10 ampere current. That is definitely a lot smaller. So let's press on. In the next step, I want to calculate the heat loss in the power. Now I better include the word heat loss in the cable. Cable meaning this cable here. Whereas the P here is the total power. Okay, including the heat loss and including all the power used by people around our place. Okay, so this P is not the same as this P. Okay, and it's the same in the last video. I mean, it's also they are also different in the last video. Right. So the heat loss in the cable happens at this rate of I squared R, where I is now 10 ampere. So I need to cross out the 4 there. This is just 10 squared, and R is still the same cable. This is still 10 ohms. So now I have 10 squared times 10, which is 10 squared times 10 is just 1,000. So it's not 10 to the power of 9 watts. It's much smaller now. It's 1,000 watts. Now that is obviously a lot better, a lot smaller. 1,000 watts is maybe about the kind of power of a microwave oven or an air conditioner in the house. So that's quite alright indeed. If you compare this with the 1 million watts of power that is produced by the power station, 1,000 watt is a tiny 0.1% of the total power, and that is obviously a lot smaller, and the loss is now is not a problem anymore, and therefore this demonstrates, this and the last video clearly demonstrate the importance of stepping up the voltage to a very high voltage first using a transformer before the power station sends out the electricity over long distances.